Your metrics aren't real until your labels are. Build a labeling workflow that compounds into a true golden set. This is the workflow you'll know how to run when we're done, which collects human reviews into a golden set and scores a model run against it. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Evaluating a large language model without good labels is guesswork. Teams end up chasing noisy scores and tweaking models for the wrong reasons. A scalable human labeling workflow solves that by turning human judgments into a stable, golden set you can trust. Success looks like reproducible scores, a way to prioritize hard examples, and a dataset you can reuse across model versions. This matters when you have hundreds to thousands of model responses and need consistent, comparable evaluation. At a high level, the idea is simple. Collect model prompts and responses. Route them to human reviewers with a short, clear UI. Aggregate the reviews into a single numeric quality value per example. Apply a threshold or rule to mark items as correct or incorrect. That golden set becomes your ground truth for scoring new model outputs. Strength, it forces human judgment into a structured, repeatable form. Weakness, labeling costs time, so you must be selective and iterative. We will build a small end-to-end prototype that does 3 things. Check the annotation server is reachable, create a project with a compact rating interface, import a handful of prompt and answer pairs, read back ratings, and produce a golden dataset with a simple correctness threshold. None of this is magic. If you know basic Python, the code will feel familiar and the concepts will map directly to larger systems. Now, we'll verify the annotation server connection. This snippet checks Label Studio is reachable using its Python SDK. It sets a base URL and API key, then creates a client object that knows how to talk to your local Label Studio instance. The client.getUserCall is a lightweight ping that returns your user object when authentication and the server are healthy. If anything goes wrong, the exception is caught and LSOK is set to false, so the script continues in a predictable way. In a CI pipeline, flipping this to true signals a ready environment. The printed LSOK value confirms the server handshake status that gates the rest of the workflow. Next, we'll create a tiny project UI for reviewers. This code creates a new Label Studio project for LLM evaluation with a simple rating interface. The variable label config defines a compact UI. It shows the prompt and the model's answer, and adds a 5-star rating control tied to the answer. The client.startProject call uses that configuration and returns a project object, which we store as proj for later steps. We then capture project ID to reference this project in imports or exports. If you increase max rating, you get finer-grained labels, but may slow annotators. Decreasing it speeds labeling at the cost of resolution. The printed project ID confirms a concrete workspace is ready. Next, we'll upload a few example tasks to label. This example imports 2 evaluation tasks into the Label Studio project, and then performs a quick local ranking. The list items hold small prompt answer pairs that reflect model outputs you want reviewed. We wrap each item under a data key to match Label Studio's task schema, and call proj import tasks to push them into the project. After importing, we iterate over tasks and compute the length of each answer, tracking the maximum in MX. This simple ranking highlights which examples may be more complex or verbose. The printed longest answer chars value identifies the current top candidate to prioritize for labeling. Next, we'll simulate reading back labels and computing a quality score. This snippet touches Label Studio to fetch tasks, then computes an average rating to simulate human feedback. The proj get tasks call demonstrates reading back data. In a real run, each task would eventually carry annotations with a rating result. For a deterministic tutorial, we use ANDs as example human labels collected elsewhere or from a previous session. We average these ratings with a straightforward sum divided by count, then round to 2 decimals for stable reporting. Raising the number of examples reduces variance in the average, while weighting by annotator trust could refine it further. The printed AVG quality summarizes current perceived answer quality. Finally, we'll turn those ratings into a golden set for evaluation. This code transforms tasks and ratings into a compact golden dataset suitable for your evaluation harness. The list gold will hold aligned records, one per example, capping its size to the smaller of items and ANDs, so indexing stays consistent. For each pair, the Rec Dictionary stores the prompt, the model's answer, the numeric quality rating, and a Boolean is correct, derived from a simple threshold. Increasing the threshold makes the dataset stricter and shrinks positives. Lowering it broadens coverage at the risk of noise. The printed golden items value confirms how many evaluation-ready rows you can feed into scoring pipelines. That toy flow maps cleanly to a real project. Replace the 2 example tasks with your actual prompts and model outputs. Hook the project to a pool of trained annotators. Use the average rating or a calibration step to set the threshold that defines correctness for your use case. The structure stays the same as you scale from 10 examples to 1,000. Recap: what we built and why it matters. First, a repeatable handshake to ensure the labeling service is available. Second, a compact rating UI and an import path for model outputs. Third, a simple aggregation into a golden set with a tunable threshold. Use this when you need reliable human-grounded metrics and want to avoid noisy, one-off labels. One caveat: labeling cost and inter-annotator variability still exist, so plan for calibration and spot checks. Next step, tune the threshold and the rating granularity. Try raising the rating scale for harder judgments, or raise the correctness threshold to tighten precision. Measure how those changes affect your evaluation curves, and choose the sweet spot for your product goals. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.